Now we move on to discussing the effect of mobility on the received signal. Usually we have the receiver to be the mobile part of the system, but sometimes we have the transmitter being mobile. For example, we have a moving satellites, right? So the satellite which is transmitting the signal is moving and you are stationary. In many cases, we have the environment between the transmitter and the receiver to be mobile. So let's say that you are on one side of the street and the transmitter is on the other side, and you have traffic between you. So the environment is mobile, is non-stationary. Okay. In any case, such mobility leads to what is called the Doppler effect. The Doppler effect is actually a shift in the frequency, in the received frequency. So in this simple case that we have here, we have a mobile receiver moving in the x direction with velocity v, and we have an incoming ray or multipath component, the kth one, which makes an angle beta with the mobile receiver direction of movement. So this leads to a frequency shift that is proportional to the velocity, and it depends on the cosine of that angle, and it is inversely proportional to the wavelength, right? So this is the shift, and the total frequency is the center frequency plus that shift. Okay, note that if the angle is around 180 degrees, we have a negative shift now here. Okay, so the Doppler shift appears as a phase shift in the received signal, as you can see here, right? So you have the phase shift due to the delay, and you have the Doppler shift here. So this causes a frequency offset, and this needs to be estimated in order to modulate the signal properly. So if we have multiple components, okay, we have this form, right? We have multiple components, we have multiple shifts, we have multiple attenuations, and we have multiple phase shifts. So here, this is an example of how the effect of the frequency shift is shown on the frequency setting that we have here. More importantly, the power, the received power. Now, see here the power changes with time. The power changes with time. So the blue part is the free space path loss. We don't have any frequency shift. And the red part is the ground reflection. We have this ground reflection, so the mobile receiver is moving away or towards the transmitter. And here we have the Doppler effect in magenta color. So you can see that we have it's more severe. The change in the power is more severe. So this means that we have to account or to deal with this effect, which is not trivial.